Welcome to the 13th lecture. We are going to study measure of center, and we'll continue that. In our last lecture, we studied the first measure of center, that was arithmetic mean or just mean. And we use a numerical formula to compute mean over a given data. Right, in this lecture, we will study median and mode, two more measures of center. Right, a median uh, is is the middle value. The median is a middle value, but only after the given data is arranged in increasing order, right, in ascending order from smallest to largest. Then the middle value is the median value, right? If measurements are even in number, then we cannot have the middle value. In fact, there will be two middle values then. If we have, for example, 6 numbers, so we cannot have a middle value. Then the middle two numbers, the arithmetic mean of the central two measurements, will be the median, right? So let's try to understand this better with the help of two examples. Example number one is this data given 2, 9, 11, 5, and 6. First, we have to rank it in the increasing order or ascending order, 2, 5, 6, 9, 11. Since the number of data items are 1, 2, 3, 4, 5, they are odd. Therefore, after we have arranged it in ascending order, the middle value is the median. The middle value is the median, right? So that's simple. In another example, we have this data 2, 9, 11, 5, 6, 27. So now we have 1, 2, 3, 4, 5, 6 data items. And now we do not have a middle value. In fact, we have two middle values, 6 and 9, because we cannot have a middle value. So we have two middle values, 6 and 9. In this case, we compute the average or the mean of the middle two values, and the result is the median, right? So that's quite simple, pretty simple. If we have odd number of data items, we arrange them and the middle value is the median. If we have even number of data items, we arrange them in ascending order and we compute the average over the middle two values, that is the median, right? And we can compute the position of the median if we have arranged our data. After that, after we have arranged the data in ascending order, the position, this is the position number 1, 2, 3, 4, 5, 6. These are positions or indexes. So at every position we have a number. At position 1 we have number 2. At position 2 we have this number 5. At position 3 we have this number 6, right? So position of the median can be computed as 0.5 times n plus 1, where n is the number of measurements. Here we have 1, 2, 3, 4, 5, 6 measurements. In this example number 2, we have n is equal to 6. But in example number 1, we have n is equal to 5. So in any case, the position of the median is 0.5 into n plus 1 in the arranged data set. If position is a fractional number, for example, it can be a fractional number. If n is an odd number, for example, 5 plus 1 is a 6, then 6 multiplied by 0.5 is a whole number, 6.23. But if it is 6, then 6 plus 1 is a 7. 7 multiplied by 0.5 is 3.5. So that's not a whole number. In that case, if n is such that this position variable is a fractional number, then we compute the average of the two adjacent values produced by this position, produced by this expression. For example, if n is equal to 5, Position is 0.5 into 5 plus 1, it's 3. So median is the third ordered number. If we have n is equal to 5, that was in example number 1. We have n is equal to 5 here, and if we arrange them in increasing order, so the answer is 3. Answer is 3. So at position 3, we should get the median. Once we have arranged it in increasing order or ascending order, 1, 2, 3. At position number 3, we get the median. That's simple. But if it is 6, n is 6, then 6 plus 1 is 7 times 0.5 gives us 3.5. This means the median is the average of the number positioned at third and fourth positions. Third and fourth. If this is n is equal to 6, this is an example with n is equal to 6. So in this case, the median is the number that is the average of the number present at position number 3 and at position number 4. So 1, 2, 3. This is position number 3. This is position number 4. So we compute the average of the two, and that is the median. Right. Mean versus median in the presence of outliers. Let's see which of the two measures, mean and median, which of these two measures is good in the presence of outliers. We have studied in chapter number 1 that outlier is a number that is very far away from the rest of the data. We have this example in which we have this data set that we used in example number 1 and this data set that we used in example number 2. In this second data set, this 27 number is an outlier because it is very far away. If we draw a dot plot, this is 10, maybe this is 20, and this is 30. So this is 30, this is 20, this is 10. And if we draw these numbers from second example, 2, 9, 11, 5, 6, and then we have a number 27, which is very far away. This number is very far away from the rest of the data. That is why we call it outlier. It lies outside the rest of the data. Outside of the rest of the data. From the remaining data, it is very far away. That is why we call it outlier. So 27 is an outlier. So if we have this data set, the mean is 6.6, the median is 6. The mean was computed using the formula summation over I from 1 to 5 xi divided by 5 that we studied in our last lecture. And median is, we have arranged these numbers in increasing order. The middle value is 6. So 6 is the median. But if we have added a 27, a number 27 in this data set. Now we have 6 numbers. The mean using this formula would be, instead of 5, it would be 6, and it will be divided by 6 because this is the new formula. Oh, sorry. Now we have the new data set. The formula is the same, but now we have the new data set. So we have to go from 1 to n, where n is 6 in this case. So the answer is 10, but for median, the answer is 7.5. This means that the variation in the mean is large when we have introduced an outlier compared to the variations in median. The median, with the presence of outlier, the change in the median is only 1.5, whereas the change here is 3.4 from 6.6 to 10. So it has moved by 3.4, but it has moved only 1.5. So in the presence of outliers, the median tends to be a better measure compared to mean. So with the presence of outliers, the mean is affected more compared to compared to the median. So if we have outliers in our data, median is a better measure of center compared to mean. Right. Types of distribution versus mean. We have, if we have symmetric distribution, we studied in chapter number 1 that if we have a symmetric distribution, it looks like this. Distribution can be skewed to the left or it can be skewed to the right. If we have a long tail to the right, it is skewed to the right. If the data has a long tail to the left, it is skewed to the left. But if it has a tail in the middle and the area under the curve on both sides is approximately the same, it is symmetric. So for symmetric data set, mean is approximately the same as median, whereas if we have a skewed to the left data set, mean is smaller than median, because with this data items, these outliers that are present in the data, the mean would be shifted to the left and would be smaller than median. The median would be shifted but would not shift as much as the mean would be. Right, and for the data that is skewed to the right, the mean would be shifted to the right with the presence of outliers, but the median won't. So median would be smaller than mean then. For skewed data, mean is a better numerical measure. If we have outliers in the data, or if the data is skewed either to the left or to the right, median is a better measure compared to mean. And the last thing in today's lecture is the mod. Mod is the most frequently occurring value or category in our data. Suppose we have this birth weight data that we introduced in chapter number 1, where we have 30 weights of 30 newly born babies in a hospital or in a community, right? And we implemented this histogram, and this histogram becomes a relative frequency histogram if we divide height of each bin by the total number of observations or total number of measurements found in our data set. Otherwise it is histogram. If we don't divide that with the total number of measurements, it's histogram. If we divide that, it becomes a relative frequency histogram. We studied in chapter number 1. So for this histogram, this class is the model class. This is not MODEL, it is MODAL, comes from model class. Model means that this class has the maximum height out of all other classes. Compared to all other bins, this bin has the maximum height. Therefore, it is model. So this means why it is model. Mod is the highest point or the most frequently occurring point. So this has the highest height. This is not the highest number. In fact, highest number would be something here. That is the most frequently occurring value or most frequently occurring class or bin. So this is actually has the highest frequency. So this is the most frequently found class in the data set. It's not the highest number. It's not the maximum number. It is the most frequently occurring number or range of numbers. And then mod can be computed as the central value of this bin from 7.6 to 8.1. If you go to chapter number 1 and see, you will find this histogram there, and you see the bin limits. They started from, I think, 5.6. Then the next was this was 6.1. This was 6.6, this is 7.1, this is 7.6, 8.1, this was 8.6, 9.1, and 9.6. So I recommend you should go to chapter number 1 to see that example once again, and you will find this histogram there in chapter number 1. So the middle value would be the mod of this bin with the highest frequency, or the bin that has the maximum height. So 7.6 plus 8.1 divided by 2, This is 7.85. So mod is 7.85 for this data, for the birth weight data. And for the same birth weight data, you can calculate mean and median. So it is being left as a homework for the students to calculate for the same mean, for the same birth weight data. Students are required to compute mean and median. Right. So it's homework. So you should compute mean and median for this data. Right. So the last thing I want to share is that mod is a measure used for large data sets. It's not for small data set, whereas mean and median are the measures that are used for relatively smaller data sets, where mod is used for larger data set and is usually applied on frequency histograms. Right, that's all for this lecture. Thank you.